Now we are going to learn about goals of a scheduling algorithm. There are various scheduling algorithms designed like first come first serve, shortest job first, round robin algorithm, priority scheduling, etc. All these algorithms are designed by keeping certain goals in mind. So these are the goals that we want to achieve through those scheduling algorithms. Those scheduling algorithms we'll see in the next module. Now we'll see the goals of a scheduling algorithm. First, maximum CPU utilization. So CPU must not be idle and it should be used to full potential. So if CPU is left idle, then we will say that it is not highly efficient because most of the time it is being idle. For what purpose it is being left idle when it can be used to its full potential? So that's why the scheduling algorithm that we consider must allow the CPU to be used to its full potential. Next, maximum throughput. Throughput is number of processes completed per unit time. So the CPU must try to execute maximum number of jobs per unit time. So the scheduling algorithm that we use should ensure that throughput is maximum. Minimum turnaround time. So we saw in the previous videos that turnaround time is the difference between completion time and arrival time. So the time difference between completion time and arrival time should be minimum, because if it is very high, then it indicates that the process has been waiting indefinitely or there are breaks between executions. So in that case, the efficiency will be low. So we should ensure that time difference between arrival and completion time must be minimum. That is, turnaround time must be minimum. Minimum waiting time. We saw in the previous video that waiting time is the difference between turnaround time and burst time. So the total time amount of time in the ready queue must be minimum. So CPU should be allocated and it should be used to its full potential. It should not wait for longer times in the ready queue. So the scheduling algorithm that we consider must ensure minimum waiting times of a process. Minimum response time. So we saw in the previous video that response time is the difference between arrival time and first it gets assigned the CPU. So the difference should be minimum because it can't be very high, right? The process can't keep waiting for CPU allocation indefinitely in the ready queue. So we should ensure that response time must be minimum. Next, fair CPU allocation. So no job must be starved. So starvation means no allocation of CPU resources. Suppose there are many processes waiting in the ready queue, but one process is indefinitely using all the CPU resources for very long time, and these processes are not able to get CPU resources. That should not be there, right? Every process should get fair CPU allocation such that all jobs will be completed. So we must ensure fair CPU allocation to all the processes. So these are all the goals of a scheduling algorithm. So the scheduling algorithms that we are going to consider must ensure all these are implemented. In that way, we'll achieve efficiency and high performance. I hope you understood all these goals of a scheduling algorithm. Next, we'll see different scheduling algorithms. Thank you.